Quick review of the exponent laws that you should already know. So, if I have numerical bases, then 8 to the power of 3 times 8 to the power of 2 is 3/8 times 2 more 8s, which would be the same as 8 to the power of 5. Or if I have the same base and I'm multiplying them, then I'm just going to add the exponents. The same thing is true if I have variables. A to the 3 and a squared would be 3a's times 2 more a's, which would be a to the power of 5, or a to the power of 3 plus 2. So if I have a to the m times a to the n, that's the same as a to the m plus n. If I'm dividing, a to the 3 divided by a to the 2, if I pulled out a common factor from the top and the bottom, means I'm going to take away an a here from top and bottom, a here from the top and the bottom, and I'm just left with that singular a on the top. So that would be the same as a to the 1 or a to the 3 minus 2. Sorry, 8 to the 3 minus 2. Same thing with the a's. If I have 3 a's on the top and 2 a's on the bottom, I take away a common factor of a from the top and the bottom, another common factor of a from the top and the bottom, and I'm just left with a to the 1 or a to the 3 minus 2. So anytime I have a to the m divided by a to the n, then that's the same as a to the m minus n. If I have brackets and I have multiple values on the inside, then if I add 8 times 7 to the power of 3, that would be 8 times 7 times 8 times 7 times 8 times 7. Or I have 1, 2, 3 eighths multiplied by 1, 2, 3 sevens, which would give me the exponent applied to the first number and applied to the second number, 8 to the 3 and 7 to the 3. So if I had a times b to the power of 3, then that's the same as if I had 3 a's and 3 b's. Or I apply the exponent on the outside to the a's and to the b's. ab to the power of m is the same as a to the power of m times b to the power of m. If I'm doing that with rational values, it works the same way. 8 to the power of 3 over 7 to the power of 3 is the same as 8 over 7 times 8 over 7 times 8 over 7, or I have applied the exponent to the numerator and I've applied it to the denominator. 8 to the power of 3 over 7 to the power of 3. Same thing with variables. If I have a over b times a over b times a over b, that's the same as a to the 3 over b to the 3. So I apply the exponent outside the brackets to the numerator and denominator. A over b to the power of n is the same as a to the n over b to the n. Now if I take a power of a power, that's the same as if I had a power inside the brackets, but then had another exponent outside of the brackets, which is also applying. So if I add 8 to the 3 to the power of 2, then that's 8 to the 3 times 8 to the 3, or 8 to the 3 twice, which would give me 8 times 8 times 8 multiplied by 8 times 8 times 8. Or I have 6 eighths now, so I get that from 8 to the 3 that I originally had multiplied by the second exponent outside, 2. If I do the same thing with a to the 3 squared is the same as 3a's times 3a's again, or a to the 6, which I get from that original a to the power of 3 multiplied by 2. So if I have a to the m, then to the power of n, it's the a to the power of m times n. So if I have brackets, I'm going to multiply it. If I'm using the exponent laws to simplify and then evaluate, this is a key component of something you're going to need to know for the quiz and the test. Simplify means turn it into a singular power. Evaluate means actually solve. So to get full marks, we have to do both. First, we're going to simplify by, in this case, if I have two exponents with the same base, I'm going to say that 3 to the 4 and 3 to the 2 are going to combine to make 3 to the power of 6. There's step 1. Now, step 2, I actually need to evaluate it. So this is 1 mark for simplifying and 1 mark for actually putting it into my calculator. 3 to the power of 6 is 729. I need both parts. If I have negative 2 to the 5 and negative 2 to the 3 and I'm dividing them, that means I'm subtracting the exponents. So 5 minus 3 is going to give me negative 2 to the power of 2. And then when I square that, I get positive 4. For example, C, if I have 5 to the 2, then to the 3, then I multiply the exponents using the power of a power rule. So 2 times 3 is going to give me 5 to the power of 6. And then I can evaluate. 5 to the power of 6 is the same as 15,625. If I'm doing the same thing and just adding variables into it, my process is still the same. With variables, I can't evaluate, I can only simplify them because I don't know what the actual number the variable is representing. So if I have a to the 4 and a to the 3, I have a to the 7. If I have x to the 6 and x to the 1, I have x to the 7. B to the 7, b to the 0, and b to the 4, 7 plus 0 plus 4 gives me 11. If I have x to the 8 over x to the 4, 8 minus 4 gives me x to the 4. If I have y to the 10 over y to the 2, then 10 minus 2 gives me y to the 8. If I have a to the 4, then to the power of 3, then I'm going to multiply them. 4 times 3 gives me a to the 12. Y to the 5, then to the 5, 5 times 5 gives me y to the 25. If I have a fraction like this, then I'm going to apply the 9 to the x in the numerator. I'm going to apply the 9 to the y in the denominator. Same thing with example I. I'm going to apply the squared to the c in the numerator. I'm going to apply the squared to the 4 in the denominator. But the 4 in the denominator, I can actually solve. So it's c squared over 16. When I get to j, if I have s times t to the power of 6, then I'm going to apply the power of 6 to both of them. S to the 6 and t to the 6. For k, if I have 2a to the 5, I'm going to apply the power of 5 to both of them. 2 to the 5 and a to the 5. And 2 to the 5 I can actually solve. It's 32, a to the 5s. When I get to example L, if I have negative 3 times p times q to the power of 4, well, if I take a negative and I'm applying a even power to it, then what happens is I have eliminated the negative. Anytime that I multiply a negative an even number of times, the negative is just gone. So then I actually just have 3 to the power of 4, p to the power of 4, and q to the power of 4. And 3 to the 4 is 81, p to the 4, q to the 4. And that's it. These are all of the skills you should have from junior high.